Hello everyone, Peeps coming at you with another Hydroneer 2.0 logic video. Today we are going to be working in the creative test world, building an OR gate. This is going to be useful in my main playthrough, but I wanted to build this up so that I could understand how it works, because for right now, this technology eludes me. So essentially, this is part of the computer system that I built where we have an AND gate. So if you think about this, a one signal gets sent out whenever this comparison matches up. But this one signal can only go through this entire AND gate when all of these signals are open. So every one of these valves has to be open and. And so this is considered to be in series. All of these lines go through the exact same path, and they all need to be open in order for this to go through. An OR gate is going to be something similar to this, but instead of being series where everything is in a straight line and all of them need to be open, the OR gate is going to work where they're in parallel. So essentially we're going to have kind of a T and a fork traffic, and the signal could go through one of a dozen different possible lines, and as long as one of the valves are open, the signal will be able to get through and go out through the bottom. So I've managed to grab a series of items that we're going to use to build this up here. So let's move our items off of the cart. Start building. Whoop. No, off the cart. And then get the cart out of the way. Okay, so how are we going to do this? First, let's take our inputs. So I'm going to take this lever, and this lever I'm going to bring over here, and let's do a 3-input system, just to show what this looks like. So we'll do 3. We got 1, 2, 3. I'm going to spread them apart. I might change this later. I don't know. Maybe it needs to be more spread apart. Maybe they could be closer together. We'll find out. But when you're test building things, the more room you have, the better or easier it is to kind of work through everything. So we can always adjust things later on as we need. Let's get our hooks set off to the side so that they are out of the way. Now, I've got in my possession here some cables, and the way that we would normally work with this is that we want a one signal to come through, and so we've got this metronome that always sends a 1 signal every 1 second. 1, 1, 1. But how I want this to work is I want the valve on my OR gate to be open if the signal makes it through, and I want it to be closed if the signal doesn't send through. So we're going to take a play from some of the other circuits that I've built, and we're going to have the metronome connected to a flip-flop, and this flip-flop, what it does is it sends out either a 1 or a 0, and it flips back and forth between the two. So every second this is going to send out a 1, a 0, a 1, a 0. And we're going to have 2 different lines, one to kind of open up and allow the parallel processing, and then we're going to have another that's going to be this AND line that would say if the 1 can make it through, great, open up the valve. If the 1 can't make it through, then allow the 0 through and close up that valve. But that means that we're going to have each of these outputs, whether it's a 1 or a 0, output 2 different directions. So let's set up our T's. And I don't know whether the best way to do this is going to be up or down, but we're going to find that out here. Actually, let's grab a few of those before we start burying them in the ground. Same with the straight cables. So this is going to be my signal that could potentially open things up. So I need this to be a valve that could open things up. And we bring that up here. So if I flip this open, that opens. If I flip this shut, it shuts. So that is there, and then this is essentially going to be kind of the same thing, but just for a different line. And then we're going to have a similar setup for each one of these. So let's get you down there. I have to get these brought up. Again, like I said, I don't know if this is the best thing to do yet. It doesn't look like that line can go through. I've got, there we are. Well, there is a line there. Okay, so electricity is coming through, it just wasn't showing it to me. So we've got one output that could come through this way. Let's get these here. I'm going to have to do some longer lines for each one of these that comes along. A T, that's going to go here, here, and then because it's just the 3 inputs, I can do that across the top, but I'm going to need 1, 2, 3, 5. 1, 2, 3, 4, 5. Get some valves. So that's going to go there, and that's going to go there. Then I need 3 more of those. Standing upright, that's right. And elbows. So if I flip any of these, it's going to open up the valve directly up the line, which are all connected in parallel. Then I have to close these lines back up. So this is going to have to come back down. So let's get one, two. I suppose that one will end up being a T. top, straight here, a T, a T, and then an elbow back down. And then just to be on the safe side so that nothing gets sent the wrong way, we can go over here, grab a diode, and the diode's going to point that way. So any signal that comes in here can go through one of these three lines, and as long as one of them is open, it's going to be allowed through and out this way. Now this is where we would do our way of being able to close it. So we could actually hook this whole system up, and I need to move it one over, but let's get the rest of this set up, I guess. So I need 3 of these. Because these have to be opposite, we're going to have to flip the signal. So let's grab our flip hook. 1, 2, 3. So flip, flip, and flip. We need valve, valve, valve. And of course, valves can't just go on by themselves. They've got to be hooked up to cables or pipes. So let's get the cables set up. There. 2 and 3. So now I can mind the gap between the cables. There and there. Okay. Now we'll bring that over here. All right. Yeah. So we have our 1 and our 0 that's being sent off. We only want 1s to ever go this direction. So we're going to use a straight right here with our validator hook so that no 0s ever go that direction. So now we can do a straight and an elbow. And so this direction will only ever be a 1 signal. So if we go over here and we say, let's get, actually, let's grab a T, because we are going to need to merge, there, that's the right one. Merge these signals. And is that the right one? Yep. So then cable or here we are. So if I flip this, that should open that valve up, which it does. Oh, and I'm not actually fully connected up here yet. I need a T. You'll do. Right here. So, because I flipped that, this is now open. If I were to close that, this is closed. I can manually close this. It doesn't open back up. If I open this one up, that opens itself back up too, because the 1 can travel through any of those lines. And again, if I were to do this or this, it really doesn't matter. If I try to close it, the 1 is going to be received, it's going to auto open itself back up. Now, how do we get it to auto close? Well, for that, remember, the no 0 ever goes down here. So I want the zeros to go this way, which means I never want a 1 to go down here. So if a 1 goes down here, let's flip it to a 0. So flip to a 0. And if it's a 0, remove it with the validator. Okay. So 0 is not allowed. But if it's a 0, flips to a 1, is allowed. Now we want that to close, which means it needs to be a 0 signal again. So we flip it back. So we'll grab another flip. And then it's going to be straight, which we can actually do a diode here, just to make sure that the data never accidentally travels backwards along that line, and then close the loop up. So that and that. So now that auto closes. So if I signal that, it opens, and if I flip it again, it closes. If I have 2 of them open, it opens. If I close one of them, it stays open. If I close the second one, it closes. So this is a multi-input OR signal that's constantly being updated thanks to this metronome signal source here. And this signal only ever outputs the valve hook. So this valve hook could be hooked up to a cable, could be hooked up to a pipe. If I wanted it switched so that my inputs would, instead of stopping it, would allow it, you just have to use a flip hook along this line to kind of switch the signals around. But otherwise, this is exactly how you want the signals to travel. So again, let's take a look at how this works. My metronome signal here flips between 0 and 1 thanks to this flip-flop hook. It then splits where a 1 could be split in parallel between any of my inputs. This is a 3-input system. If it was a 4-input, then it would just go up and do the same thing, and the system would just be a little bit longer. Really doesn't make a difference how many inputs you have. You just have to worry about your build space. Each one of these has 2 different states, a 0 or a 1. So if it is a 1, the valve here opens, the valve here closes. If it is a 0, the valve here closes, the valve here opens. Because these are flipped, they are exactly opposite of each other. And that is the same across all 3. So a 1 is allowed through. We want zeros to go through, so we flip it, block it if it's a 0, which means that if it's a 1 that comes through, then it's blocked. And then we flip it back to a 0, and then use diodes to prevent data from traveling or backwashing into the system, so that that doesn't go through. If any of these are allowed open, then 1 is sent, a 0 is blocked because these are all closed, and the system will constantly refresh itself because the signal source is constantly being sent once every second. 1 second that way, 1 second that way, so it doesn't overwhelm the valves, which if they receive 1 signal every 1 second, have a tendency to just get stuck in an open state, which is something I found as I was doing some testing with valves in another build. So that is a multi-input OR system that allows for conditional reset. If you just wanted the OR without the condition or the unconditional reset, that would be the segment that you're looking at here. But the conditional reset or unconditional reset That includes the OR branch and the AND branch here, so that you can hook this up to your valve and get it so that it will open and close based off of your inputs here. I hope that a build like this is something that you'll find useful in your logic builds and as you work to automate your Hydroneer systems. And I really thank you for your time watching today. I hope that you have a wonderful time in your Hydroneer builds. And as always, thank you for watching. Take care.